Okay, so this is a kinetic questions, and we're given a bunch of experiment or trials with varying concentrations, and we are also given the initial rate for each experiment. So here we have a balanced reaction, and our goal is to find the rate constant. But before we find the rate constant, we need to first find the rate law. So if you start with the rate law, rate is equal to K, and the concentration of the one of the reactant, ClO2 to the power of X, and OH minus to the power of Y. So we choose the two experiments whose concentrations of the one of the reactant is equal, and I see that 0.2 and 0.2. So to find the variable Y, I can start with experiment 3 and 2 so I can knock out the concentration of ClO2. So when you write the rate law, starting with experiment 3, and I usually put the higher one on top over experiment 2, I'm going to have a rate, initial rate, that's a 0.00828. 0.00828 is equal to K, and I'll say 0.020 because I'm on the experiment 3, 0.020 to the power of X, and hydroxide has a 0.090 to the power of Y. And for the experiment 2, I have an initial rate of 0.00276 K, the rate constant that depends on temperature, and 0.020 to the power of X, and 0.030. So if you just do the ratio of experiment 3 and 2, we can see that K's cancel, and the 0.020, the concentration of the ClO2, cancel. And we know that this is the rate ratio becomes 3, because 273 times 3 give you around 0.008 or 828. So we get 3, and 0.090 divided by 0.030 is going to give you 3, and we can pull out the power out. So now you can see Y equals 1. So the order of the hydroxide with respect to our experiment becomes 1. Okay, now we determine that we can also find the variable X. So this time we can choose experiment 2 and 1, and experiment 1 is definitely bigger. I'll choose experiment 1 on top and experiment 2 on the bottom. So I have a rate 0.0248 divided by 0.00276, and is equal to K. They cancel, and we have 0.060 to the power of X divided by 0.020 to the power of Y. The concentration of hydroxide will be equal in both experiment 1 and 2. So 0.030 to the power of Y, 0.030 to the power of Y. So you can cancel out the 0.030s. Now, if you find this ratio using your calculator, you should get something like 9-ish. So I'll double check it for you guys. So 0.0248 divided by 0.00276. And as I had expected, it's around 9. So we have 9 here, and the K's cancel. 0.060 divided by 0.020 will give us 3. Oh, I have to put X here, my bad. So I have exponent of X. So we know that X has to be 2. So if I rewrite our rate law, rate is equal to K, concentration of ClO2 to the power of 2, and the concentration of hydroxide to the power of 1, but we don't need to write 1 on top. So now our ultimate goal is to find the rate constant. So what do we do here? Choose any experiment. Now I like to play with less numbers. So I'm going to choose experiment 1, but assuming the temperature is constant, which it should in the experiment, it doesn't matter which experiment you choose to find the proportional constant or rate constant. So I'm going to choose experiment 1. So according to the first row, the rate or initial rate is a 0.0248 molarity. Now we have a K here, and okay, carry out the unit as well. So ClO2 in the experiment 1 has the 0.060 molarity squared, and the hydroxide we have 0.030 molarity. Now the reason why I mentioned you want to have the molarity is that when we find the unit of K, you can cancel out the units using unit cancellation or dimensional analysis. So I'm gonna just say K is equal to 0.060 squared and 0.030. We have a unit of m cubed here. Oh, actually this gotta be divided. So K equals that. So m cubed on the bottom. And we have 0.0248 molarity. Okay, it's a molarity per second. Okay, so let's just put all this in calculator. 0.0248 divided by 0.060 squared divided by 0.03. So when you do that, you get 229.62. So K equals 229.6296. We have a molarity on top and we have molarity on the bottom, molarity cube on the bottom. So when you cancel out the molarity with the top one, you're gonna get molarity squared on the bottom. And we have a per second. So when you rewrite this, you're gonna get 230 if you keep 2 sig big. Molarity to the power of -2, s to the power of -1. Therefore, the third answer choice here is correct. Okay, hope this helped.